Okay, so the next thing I want to talk about now is how we have taken our colors and shapes and made an image of the world around us. So let's imagine we were looking at one of these pictures. Maybe let's look at this one down here, and so it certainly looks like there's a kind of a grey a grey top here and a sort of lighter grey, maybe white thing underneath. I suppose if we were to rotate that around, we might see something that looks a little bit like this. So that would be the shape A, and that would be shape B, and that would be the floor there. So I guess that's kind of what we're imagining when we're looking at that. But what we have to realize is that we're looking at a two-dimensional image. The image that the picture that I've just drawn in pink there, that's just an imagined thing going on. And this is what we do all the time whenever we look at things. We look at essentially all we're actually looking at is a shape of grey and another shape of sort of grey white, and we look at these shadows and other colours and lighter colours, and we kind of make an assumption of what we're looking at, what this actually is. And so because of that, we see the bottom bit and we say, well, that's in the shade because it's covered, it's being covered by, and there's a shadow there. So clearly that's in the shade, and then that's in the that's exposed to the sky, and so that's going to be brighter. And so because of that, we say that's a white color and that's a grey color. But here's the weird thing: what I've done here, in fact, what I've done here is I've taken a part of the picture and I've chopped it in half. And when I take B, which was this bit down here, let's just shrink it a little bit. You can see that when I let go, it is in fact the same color. But look at this; it's actually the same color as A as well. So that and that is actually the same color, even though it doesn't look that way. If we look at it, do the same with the other one. Obviously, A is the same color. Come off it there, but it's also the same color as B. So A and B really are the same color. It doesn't look that way because, well, because we are using our imagination to imagine what situation we're looking at here. So we do the same thing over here. We've got C, B, and A, and they are in fact all the same color. So I don't know if those. I should be aware. I can prove this. I did actually take a chop a little bit off one of these colors, but I'll do it again now. So I've just chopped off a bit of C there, so we can see that it's the same color. And we put it next to C, and obviously it's the same color. But then we go to B, and oh my god, it's the same color. It doesn't look the same color, does it? It's almost like it when I moved it towards B, it changed color, but it really didn't. If I do it slowly, you can see I'm not changing the color of it. And it's the same colour as A as well. Very, very surprising. It's very difficult to override this illusion, even though we now know it's the same colour. Even when we look at it, we're still seeing different colours. I can keep repeating the experiment to show that it really isn't a different colour. It really isn't a different colour, but it still seems like it is a different colour. And again, it's because we're using our imagination. We're saying this side here is all in the shade, whereas the top is not, and that's exposed to the light, and so is this bit here. And so we would presume the B would have to be a brighter colour, but it's just because of context. So in other words, what we do when we're looking at things, looking at the world, is we're really just seeing nothing but shapes and color, really. But we are then interpreting those to be a particular thing. I mean, this picture here is made up of pixels. If I looked really closely at it, and I can't look any closer there, and it would make you'd have to get a magnifying glass out and look at your monitor, but it's actually broken down into pixels, and each pixel has got a different color, and then together we kind of put it together to make an image. But even though our reality is made up of pixels, the backs of our eyes essentially have similar sort of setup. We have a limited number of these photoreceptors, which are over here, and each one is detecting a particular wavelength of light, or is stimulating in a particular way, and as a result, we piece that together as like a jigsaw puzzle, and then we have a kind of full picture, and then our brain takes over and tells us what that full picture means. And we can do all that so quickly that we're able to see moving images and process the whole image in a split second. And then when the image changes because something's moved, we can process that new image and then put it all together and work out what's actually happening. So that's very, very impressive. So that's, we can, with these illusions, we can see that there's something going on that doesn't quite make sense. Now let's have a look at this one here. This is another illusion, a kind of a famous illusion. Wasn't a deliberate illusion actually. So I believe the story behind this is that somebody was just trying to sell a dress, and they posted the dress somewhere and for somebody to buy. But the problem was that it was advertised in a particular colour, and there was all these other people saying, "Why are you advertising at this particular colour when it's clearly not that colour?" So the question is, what colour do you think this dress is? So you might want to decide what colour it is, but not say it, and then maybe ask a few other people in the house and anybody that's with you, say, what colour do you think this dress is? The answer is actually, I don't actually know what the actual answer is, but I'll tell you what I see when I look at that. When I look at that dress, I see white and gold. I see this top bit here is gold, and the other bits are white. But it's the reason why I see that is because my brain has decided that there's a particular quality of lighting in that room. I've done this subconsciously, and I don't seem to be able to override it, but that's the colour of light. That's the type of light I assume is in that room. Now, you might think there's a different kind of light in that room, and as a result, you'll see different colours. I think the other colours that people see are black and, I've forgotten, black and blue maybe, or something like this. But I see white and gold, and I find it very difficult to understand how you can see the other colours. The people who see the other colours will find it very difficult how I can see white and gold. So, our imagination is very important for how we see the world, and it can be tricked, as I've just demonstrated. This is a different kind of illusion. This isn't a trick as such. What's happening here is we're seeing a negative of the person there. Now, this is essentially helping us to understand a little bit more about how we see colour. So if we go over back to our cones and rods, we can actually see all the different colours, despite the fact we've got these three cones. And the way we do it is by combining these different information from these different cones to work out what colour or what wavelength of light we must be looking at. However, it can be that can be tricked, and it is tricked by computers and TVs. So, for example, it says here this rectangle contains no yellow light apparently, and the reason, and that's true. There's the inside of a computer monitor has just red, green, and blue. I've got some. There we go. This is what a computer monitor would look like if you, more or less, when you look closely at it. Just made out of red, green, and blue LEDs. So, how is it that I'm able to see yellow here? What happens is it shines red and green light, and strangely enough, when you shine red and green light, you see yellow. So let's look at the picture of the cones again. Red and green. If I shined yellow light, my green cone and my red cone both detect some light. That's what happens when I see yellow light. So if I shined green light and red light, the experience would be the same. It would seem as if I was actually seeing yellow light, and so that's what happens. They shine that there, although it looks like yellow to me and to you, it's actually just green and red light, believe it or not. If you've got a magnifying glass, actually not magnifying, a microscope out, and looked at a screen of yellow, you would see LEDs of only green and red. There's a cool little trick you can do here actually, which is going to relate to what we see over there. If you were to pause the video and say look at one of these squares for about 20 or 30 seconds, and then look at this white square, you will see the opposite colour. Now to work out what the opposite colour is, we look at this colour wheel, and the basic adding primary colours. So the opposite colour of red is this one here. It's basically what white light looks like if you remove red light. The opposite of blue is yellow, opposite of green is magenta, and so on. You can do it the other way around as well. Opposite of magenta is green, opposite of cyan is red, and so on. So if I looked at that one for a while and then looked at the white square, I would see that colour. If I looked at this for a while and looked at the white square, I would see that colour. So you could pause the video and have a little play around with it by staring at one of the colours for say 20, 30 seconds and then looking at the white square. Okay, so feel free to have a go at that. And once you've done that, we can look at a slightly more interesting one, which is this one here. If we zoom in, we'll do it a bit better. And this is now a combination of all the different colours. If you look at the bit in the middle there for quite a while, and then pause the video, look at the point on her nose, and then look at the point over there, you will see the inverse of all this. So the blue, what does blue look? The opposite of blue is kind of a yellow colour. So it's not just blue, is it? It's like a number of different colours going on there, but you'll probably see a sort of skin colour there, and this is very white. So this is probably going to be a kind of a black over there. So the reason why you see the opposite is because while you're staring at a particular colour, while you're staring at a particular picture, the cells at the back of your eye, the receptors at the back of your eye that are sensitive to particular colours are getting tired. And when they get tired, they when you look at white light, they don't seem to be detecting the colour as well. And so the ones that didn't get so tired, they're overactive, and so you see the opposite colour. So you can try that as well by pausing the video. I'll just zoom in again. So you can pause the video here, and then have a look on the screen and try that experiment out. So yeah, I think I might just stop the video there then.